All right, guys, we're still looking at lesson 10.1. We're on task 3, and we're going to look at how to write a linear inequality. All right, it says you can write a linear inequality from its graph. We've done this with equations. Now we're going to do it with inequalities. All right, so let's look at the graph. All right, there's a few things we can see given the graph. And we can see that the y-intercept is 10, so b equals 10. And we can see that the slope is rise 2, run 1. So the slope, 2 over 1, is 2. So you can quickly write an equation, y equals mx plus b. Now, we can see that this is shaded above, which means greater than. And we can see that it's a solid line. Remember, a solid line means greater than or equal to, means the points on the boundary line are included in the solution. And so we can just fill it in there. All right, I did write b here, y equals mx plus b instead of mx plus 10. So let's put a 10 here. All right, so very quickly I could determine what this inequality is by looking at the graph. Okay, so if you know how to write a linear equation, you can do the same thing with inequalities. You just have to know which inequality symbol to include. All right. All right, it says write an equation for the boundary line. So they wrote the equation first. Y-intercept of 10, slope of 2, and they did the same thing I did to start with. And then it says determine the inequality symbol. Shading is above the boundary line. The boundary line is solid, and the inequality is y greater than or equal to 2x plus 10. So they kind of went through the same steps as I did by finding the y-intercept and slope first. All right, it says the inequality symbol greater than or equal to is a combination of a greater than symbol and an equality symbol. In this case, which of these two symbols is affected by the location of the shading? All right, so the shading is the greater than symbol. All right, which of these two symbols is affected by the appearance of the boundary line? Okay, so they're talking about the greater than and the equality symbol. So the equality symbol affects the boundary line, whether it's dotted or solid. All right, it says check using substitution. So remember in the last task, we chose points and we plugged in the points to see if it was true or false. That way we could tell if the points were part of the solution or not. So they're taking a point, negative 10, 0, and they plugged in negative 10 for x, and they're checking to see if it equals 0. So 2 times negative 10 is negative 20. Negative 20 plus 10 is negative 10. Is 0 greater than or equal to negative 10? Yes, 0 is greater than all negative numbers. So that is a true statement. Okay, another boundary point they're going to check, negative 5, 0. So they plug negative 5 in for x. Negative 10 plus 10 is 0. Is 0 greater than or equal to 0? Yes. Okay, so this checks the region, and this was to check the boundary line to make sure it's supposed to be solid. And we got true for both of those. All right, how do you know whether a point on the boundary line should be included in the solution? All right, so if it's a dashed or dotted line, it would be not included. If it's a solid line, it would be included. All right, it says a point not in the solution region is 0, 0. So 2 times 0 is 0, plus 10 is 10. 0 greater than or equal to 10. That's a false statement. 0 is not greater than 10. So note that for the same boundary line, there are the following related inequalities. All right, usually I don't do the turn and talk because I don't have you guys in class to turn and talk to, but we're going to look at this because I like this example here. So basically it says shown below are 3 graphs related to the graph in task 3. What inequalities represent each of the graphs? All right, so again, we can look at the equation, and I'm going to look at this one first. It has a y-intercept of 10, and it has rise over run, so it's still same equation. So it has a slope of 2. This one's going to be greater than, because it's a dashed line. It's going to be 2x because the slope is 2 and the y-intercept is 10. All right, so this one has a y-intercept of 10. It has a slope of 2. So this one's going to be y. This time it's shaded below, so it's less than, and the line is solid, so it's less than or equal to 2x plus 10. So the line's the same, the shading is different. All right, and the last one, the third one, y is a dotted line, and it's below, so it's less than, and then 2x plus 10. You can see the y-intercept there at 10, and you can see rise 2, run 1. So they all have the same boundary line and the same slope, but the difference is this boundary line is not included, so we have no line under this, and same with the third one, but the middle one, the boundary line, is part of the solution, so that's why it's less than or equal to. All right, that's all for task 3. If you have any questions, let me know. All right, guys, lesson 10.1, task 4. All right, it says model with linear inequalities. A realtor has a budget of $200 for cheese and crackers for an open house. The crackers cost $4 per package, and the cheese costs $8 per wheel. Write a linear inequality to describe this situation. Graph it, and then use the graph to identify 3 possible combinations of cheese wheels and boxes of crackers that stay within the realtor's budget. All right, so it says use a verbal model. All right, so we know that cheese costs $8 each, and we don't know how many we're going to have, so we're going to call the number of cheese wheels X. Boxes of crackers cost $4 each, and we don't know how many boxes of crackers yet, so we're going to call that Y. And we know that it has to be less than or equal to $200 because the realtor has $200 to spend on cheese and crackers for the open house. So that means she can't spend more than that. All right, so it says, why is the symbol less than or equal to being used? Because the realtor must spend less than $200, because the realtor must spend no more than $200, because the realtor must spend more than, because the realtor must spend at least. So we know it's not more than or at least, because both of those would exceed $200. So the first two, we have to choose the best one. So it says less than or equal to. It says the realtor must spend less than, well, they can spend up to, so the realtor must spend no more than $200. So no more than means less than or equal to. So that's your best option. All right, so it says write an inequality in standard form. 8x plus 4y less than or equal to 200. All right, so that's coming from the verbal model here. 8x plus 4y less than or equal to 200. So they just wrote it as a standard form inequality. And then it says identify the x and y intercept. Okay, remember we found the x and y intercepts by substituting for 0. So if we say 8 times 0, we can call this an equal sign for now because we're just trying to find the intercept. So this is going to cancel. Divide by 4. 4 goes into 20 5 times. So what is that? 50. And then the other equation would be 8x plus 4. Substitute 0 in to find the other intercept. And then this would be 0. Divide by 8. So x equals 8 goes into 16 twice with 4 left over. 8 goes into 40 5 times. All right, so your x and y intercept. So when x is 0, y is 50. And when y is 0, remember y is your second ordered pair, or second variable in your ordered pair. So that gives you 0, 50, and 25, 0. All right, so they've solved it the exact same way. So they found x is 25, okay, and they found y as 50. Good. All right, so now it says graph the inequality. All right, so once you find the intercepts, you know the x and y intercept will be located on the x-axis and the y-axis. So that's an easy way to graph it when it's in standard form. So you can see here they have went to x, so 25, 0. So they put a point at 25, 0. And they put a point at 0, 50. Okay, and then they drew the line between that. And since she has $200 to spend, the points on the boundary line would also be included. Okay, so less than or equal to would be shaded below. Now, we're trying to purchase cheese and crackers, so we only need quadrant 1 because anything in the negative region in quadrants 2, 3, and 4 would not apply when you're talking about a real life situation like buying cheese and crackers. So that's why we're only in quadrant 1. All right, so it says, why is the boundary line solid? Select the explanation. All right, so the explanation is, let's see what our choices are. Because the inequality symbol means less than or equal to. Because the inequality symbol means less than. So we know it's going to be less than or equal to. And then how do you know which half plane to shade? Well, we know she had $200, so she has to spend less than $200. So the less than part of the symbol indicates that the half plane should be shaded below the boundary line. All right, it says identify 2 points in the solution region, confirm that they make the inequality true, and interpret them in the correct content of the situation. So 1 point in the solution region, 10, 15, so you plug it in, and that's true, so we know that that's shaded correctly. All right, so it says the realtor can buy 10 wheels of cheese and 15 boxes of crackers. All right, another point in the solution region is 15, 20. That is true. So the realtor can buy 15 wheels of cheese and 20 boxes of crackers. All right, so here's 20 cheese wheels and 10 boxes of crackers and 15 and 20 and 10 and 30 and then 5 and 40. Okay, you got to just kind of make logic, you know, what's logical with how much crackers do you need to go with how much cheese. So I have to take that into consideration too, I guess. All right, it says, why isn't 545 a solution? Select all choices that apply. So if we look at 545, 5 and 45 is outside the shaded region, so it's not a solution. All right, it says because the point 545 is loaded inside, no. Because it's located outside, yes. Because 5 cheese wheels and 45 packages of crackers cost $220, which exceed the amount, that's true. Because this costs $300, that's not true. Okay, so you can take 5 and 45 and plug it into here and see what it is equal to, and it's going to be equal to $220. All right, is every point within the solution region an acceptable solution in the context of this problem? And the answer to that is no, because like I said, you can't buy a half a box of crackers and you can't have negative numbers when you're talking about real situations. So there's only a few situations that's going to make sense. And again, you don't want to have 25 cheese wheels and no crackers, so you don't even want to have the x or y intercepts either. You want to find something kind of close to the middle. That would make the most sense. All right, that's all for task 4. If you have any questions, let me know.